Okay, well, something very interesting about roots. Let's say I have something like this. And I want to get all my radicals out of the bottom. Well, I could try multiplying the top and the bottom by root 2. I could try that. I'm going to run into some problems because I'd have to multiply both of these terms by root 2, and root 3 times root 2, that's root 6. That's not going to really help. I could try root 3. That's not going to help either. But there's a trick. Whenever I have an expression of the form a plus b or a minus b, what I can do is I can multiply by what we call the conjugate. So the conjugate of a plus b is a minus b, and the conjugate of a minus b is a plus b. There's actually special symbols used for the conjugate. They're not used so much at this level when we're taking conjugates of roots, so I'm not going to introduce those symbols. Just in general, if I have the conjugate of a plus b, it's a minus b. If I have the conjugate of a minus b, it's a plus b. So what I might want to do here is I want to see what happens if I multiply by the conjugate. Because if I take conjugates and radicals, something very nice happens. Now, I can't just multiply the denominator by the conjugate, even though I might want to, because maybe I want the problem to end sooner. But I also want to get an answer that has something to do with reality, or at least mathematical reality. So what I'm going to do is I'm going to multiply by 1. There's only 2 tricks. One of them is you can multiply by 1. So what I'm going to get in the top is going to be root 2 plus root 3. But in the bottom, let's see what happens. I get root 2 times root 2 plus root 2 times root 3 minus root 3 times root 2, and then minus root 3 times root 3. So something very special happened. Obviously, when I take the roots and I multiply them, those symbols are going to go away. But for the other 2 terms, since we have 1 plus and 1 minus, these 2 cancel out. And that's why we didn't want to multiply by root 2 minus root 3, which is what we had here. I needed to take the conjugate because I needed these 2 root 6's to cancel. Okay, so what do I get? I get root 2 plus root 3 over negative 1, because 2 minus 3 gives me negative 1, and that's just going to be equal to negative root 2 plus root 3. And just in case you're not sure why this is equal to this in this last step, I just want to emphasize that if you have minus a over b, that's the same as a over minus b, which is the same as minus a over b. So I can pull that negative right out using this rule from here to here. And then I just have a 1 in the bottom, and anything divided by 1 is itself. So that's an example of taking a conjugate in order to rationalize something that has a difference of radicals. And we'll look at some more examples coming up.